So we have today an essay mentioned last time. It's going to be a little bit about definition. And 1 tip for you for this quiz, okay? All right. So for dependent motion, most of the problems that I discussed last time, it was like that you have one fixed surface, okay? Like for example, I have a bully here, maybe something like this, and I have a weight or something like that. And for example, this bully is something like this. This is only one cord or one rope or one wire, and that's why we only have one equation, right? If I have 2 wires, I'm gonna have 2 equations. Why? Because each wire has a constant length. It's not gonna change. And you can work your problem either counting all the lengths of the rods and say that the length of the rod is this piece plus the piece here plus this piece and this piece, or you can get a fixed datum and try to look at the moving parts. This as a moving part, and this is a moving part, and this is a moving part. This part is always constant, and this part is always constant. And then you sum, like for example, if you call this a distance, something like this, and then like for example, this is YA and this is YB, so you have YA plus 2YB, and then they are equal to constant, right? If you have 2, you will have to focus on the 2. But let's say if we have 2 datums, like 2 fixed datums, like for example, all right, like if I made something here, fix it, okay, and I got like, this one is connected to the ground, another, let's do it with different color. This one is connected to the ground, and let's make it green. Okay, so we have one cord here, and I'm gonna make another cord here. But this cord somehow is connected to different data, okay? But it has a fixed length. Like if I have a weight here, so what you are gonna do, you are gonna relate your equations to the other data for the other rod, right? Because this is the datum for this rod, and this one is fixed here. And then you need to find out how to relate this rod with this rod, okay? How can I relate that? Okay, so right now, if this pulley get up, this distance is gonna be shorter, but this distance is gonna be longer, right? If this pulley goes down, this distance is gonna be shorter, and the other one is gonna get longer. So what is the relationship between the 2 cords? Yeah, but they have like, this distance from here to here is constant, right? Like if this one is YB and this is one YA, if this one gets bigger, this is getting smaller to maintain the same distance between the fixed. So this is how you can relate both of them to each other. Okay? So this is the tip for the quiz today. It's gonna be maybe a different problem, but the general idea is like if you have 2 fixed datum, they'll get chopped. Okay? So measure from here and try to relate them to each other. You will have an equation that comes from the length of this rod is constant, and another one that the length of this rod is constant, and another one that this plus this is constant, right? Okay. Perfect. So let's start our lecture today. So today we are gonna start a new chapter. There is one sub-chapter in the book. It's called relative motion. I'm not gonna get into the relative motion because we have other topics beyond the Kepler textbook that we need to cover. So there's some parts that I'm not gonna go in deep in to give you new topics related to structural engineering application at some point in this class, okay? So we are kind of saving time for other things. But today we are going to start with chapter 13, which is a very, very important chapter. So chapter 13, which is talking about Newtonian kinetics. And the main equation in this chapter, we are going to see it in different forms. It's called the summation of the force. It's the Newton's second law. So do you guys know what is Newton's second law? Yeah, the force is equal to the mass multiplied by the acceleration. By the way, this is an empirical equation, a proved empirical equation. It came from it's verified experimentally. How it was verified experimentally? They found out if you have a body and this body is affected by unbalanced forces, like this forces is unbalanced, because if the forces are balanced, the body is not gonna move. Like if you have a body like here and you have force F and you have another force F and both of them are equal, this body is not gonna move. Okay, so the acceleration is equal to 0. But if we have unbalanced forces F1 and F2, this body is gonna move. So let's assume that the resultant of these forces is something like this. So this is the F resultant. So this body is gonna move this way, and we found out that it moves with an acceleration A, and the acceleration A is a function or is a proportional to the resultant force. If the resultant force increases, the acceleration is going to increase. And experimentally, we found out that the proportionality factor is the mass. Okay, experimental. So this is an empirical equation or proved one. So FR is equal to MA. But before I start this chapter, I need to make sure that you guys know some units. You can differentiate between the mass and the weight. Do you guys know what is the difference between the mass and the weight? Let's write this here. So let's say that our average weight here, let's say not weight, the mass. Like let's say that we around like 100 kilograms. Okay. So I know that you guys, most of the things you refer to pounds, but let's do our example in kilogram. Is that a mass or weight? Mass. Do you guys know how can I convert this mass to weight? How? Let's say the weight. The weight is gonna be equal to mg, right?
Well, first we have to convert to grams.
To grams? No, we can do it from kilograms.
Yeah.
Okay, so we have 100 kilograms. Do you guys know what is the gravitational acceleration? 9.81, right? So this is going to be 981 Newton. So, or you can write it as, this is the unit is meter per second squared. Newton is equal to kilogram meter per second squared. Or we can say Newton. All right, so let me ask you a question. Do you guys know where is this coming from, mg? Like why the weight is equal to the mass multiplied weight as a force. So I'm gonna give you a little bit hint that's out of this class. It's comes from the Newton's gravitational attraction law. So it says that the attraction, like in my body, is attracted to everybody here. Like I have an attraction to each body. It depends on our masses. Like my mass is attracted to anybody here. It depends on my mass, your mass, and the distance between each other. So the Newton's law of attraction says that the attraction force between two bodies is equal to the mass of the first body multiplied by the mass of the second body over the distance between two bodies squared multiplied by g, where g is the universal constant of gravitational attraction. Okay, so this g is equal to 66.73 multiplied by 10 to the power negative 12, and it has unit meter cubed per kilogram second. Okay? All right. So how to get the g? So like right now I am on the surface of the earth, right? So it's my attraction between my body and the earth. So if this is the earth and this is my body, like let's say I'm here, okay? So I have a mass m and the earth has a mass me, and this is the radius of the Earth, so the distance between the center of this body and my body is the radius of the Earth. Neglecting my distance to the Earth because the radius of the Earth is like something to the power 6. So if I'm like 2 meter, 3 meter, 300 meter, it doesn't make any difference with thousands of kilometers of the radius of the Earth. So if I substitute in this equation, so the mass of the Earth multiplied by my mass over the radius of the Earth squared multiplied by g. So the value of these, once you do them, like if you substitute, like go Google the mass of the Earth, I put the numbers here, and the g and the radius of the Earth, you'll find that this is equal to g multiplied by m, where g is equal to g multiplied by the mass of the Earth over r squared. So this is where it's coming from. All right, so let's get back here. What if my units are in bounds? Like let's say my weight is like 190 pounds. Is that a mass or weight? It's a weight, not mass, right? So this is, so if I give you a problem that somebody is 190 pounds, so this is directly is a weight. It's not a mass. So if you want to substitute in the Newton's second law and you have mass by acceleration, what should I do with this? Because this is weight and I need mass. So how can I get the mass here? Divide by g, right? But what is the value of g in, because this is pounds, so my units are English, or are American, so I need to divide by the gravitational acceleration in American units, right? So g, 32.2 feet per second squared. So I need to divide 190 by 32.2. Do you guys know what is slot? Perfect. All right, so this is very, very important when you solve problems, okay? All right, so let's get back here. So this is the Newton's second law. So you have the sum of the forces equal to the mass multiplied by the acceleration. So all the problems in this chapter is based on this rule. So we are gonna take like 2D Newtonian kinetics, like XY. So this is gonna have two components. One, that the sum of the forces in X is equal to MAX. And the sum of the forces in the Y is equal to MAY. And when we get to tangent normal, it's gonna be the same thing. The sum of the forces in the tangent direction is equal to the mass A tangent. Sum of the forces of Fy is gonna be, sorry, not Y, it's normal. MAN. Polar coordinate system, same thing. Fr is equal to MAR. Sum of the forces in the theta is gonna be MA theta, right? So this is if you have 2D XY coordinate system, Cartesian, and this is one if you have tangent normal, and this one if you have r theta. So the same thing is dependent on this rule. However, in some of the problems you will have to do some kinematics. What is the difference between kinematics and kinetics? Kinematics, when you want to do relationship between position, velocity, and acceleration, that means kinematics. Kinetics is motion, like includes MA. So sometimes I don't give you A directly. I tell you that this body cut a distance of 20 meters in 2 seconds. Find A. So you'll have to use the formulas, relationship between position, velocity, and acceleration to get A, and then solve the kinetics problem. So you will have to solve kinematics problem before you get to the kinetics problem to get the acceleration, and then use this formula. Okay. Then you need to figure out what is your problem coordinate system is. Like, is it 2D Cartesian, or is it tangent normal, or is it r theta? Okay. So this is mainly the whole chapter is going to be around these rules. But let me write the steps that you need to follow when solving any problem. First, you need to understand your problem. What is this body's doing? Is it sliding? Is it static? Is it attached to a spring? You need to understand how's the problem look like. So once you did this, let's write here the steps to solve problems. Number one, you need to choose a body to isolate. I'm gonna give you a big problem. A body is attached with a cord and there's a spring on the other side. So you'll find your problem big, but you need to focus where's the body that is moving and isolate it, okay? Number two, pick a coordinate system. Like you need to identify is your problem is gonna solve in Cartesian or tangent normal or r theta coordinate system. Before pick the coordinate system, let's make this 3. Number 2, draw a free body diagram. Okay. So it can be 2 or 3, doesn't matter. You pick a coordinate system before or after drawing the free body diagram. What is the importance of drawing a free body diagram? In every problem that I give you in the exam or a quiz or something, you need to draw a free body diagram. If you didn't, you are gonna lose points. So if you solve the problem and you give me a perfect answer and the answer is right, but there is no free body diagram, I'm gonna it's gonna be suspicious. How did you figure out how these forces connected together? What does I mean by a free body diagram? Let's say that I have, for example, like I have an inclined slope, something like this, and I have a body is sliding on this slope. And I give you all the information about this body. I give you the friction coefficient of the surface, the body mass, and everything. So what you want to do is to isolate this body and show me all the forces on this body. We draw 2 things. We draw a free body diagram and kinetic diagram. So the free body diagram should have the axes, like let's say that this body is moving down, but you decided that you put the x-axis is going up, and we always make the x-axis in the same line of the motion of the body. So x is moving this way, and I have y this way. You can make x is horizontal, y horizontal. It's up to you, but this is gonna make my problem much easier. Okay, and then I have to assume the direction of the acceleration. So if I give you that this body is moving down, so I would assume maybe the acceleration is this way. So the mass multiplied by the acceleration is in this way. So this is called kinetic diagram. You need to draw this. You are gonna get points once you draw this. How? By showing me what coordinate systems that you picked. So right now I see that you picked Cartesian coordinate system x, y, and you showed to me where did you assume the acceleration is going. Is it down or is it up? So the mass multiplied by acceleration is moving down. You can assume it up, whatever you want. So then once you solve the problem, if you find the acceleration is negative, that means that you assumed it in the wrong direction and it's in the opposite direction. That's fine. Then the next step is to draw, let me clean this. The free body diagram. So the free body diagram has the forces, the free body diagram. I'll take this body here on the same slope. I'm going to have something like this. This is the body. And then I put all the forces on this body. Let's assume that I have a theta here. So this body has a weight goes down. You put all the forces on this body. Let's assume that this body has a weight goes down. Because I'm going to give you a mass and then you get the weight. Then let's assume that this body, like somebody's pulling this thing like this way by force B. So you put the force B. If this body, I give you the problem, somebody has a rope or has a cord that is pulling this body. If the force B was an angle, whatever the angle is, phi, okay? And then, since this body is resting on a surface, anybody's resting on a surface, like if I have a body resting on a surface like this, it has a weight goes down, and there is definitely a normal force goes up, right? Because if there isn't a normal force that is restraining this body this way, it's gonna fall, okay? As soon as there is a weight, so there is normal force goes up. So what is the direction of the normal force? It's always perpendicular to the surface. So if my body is something like this, so it's perpendicular to the body, like to the surface that the body has. Okay, so this is like this, so it's always perpendicular. All right, so I have N is this way. Do I miss any forces? This body's moving. It's gonna make a friction, right? So, and what is the direction of the friction? We assume that the body is moving this way and the acceleration this way. So the friction is always in the opposite direction of the movement. So let's assume in the example, you assume that MA is going in the positive x direction. So the friction is in the negative x direction. So don't put them and have the same sign. If you did, it's gonna be totally wrong. Okay, so I assume my body's going down, so the friction goes up, and friction. So in the free body diagram, you put all the forces on the body. I put the external force, I put the reaction force from the surface, I put the friction, I put the weight, all the forces. If I told you that this body is moving on a smooth surface, that means that the friction is equal to 0. But I have to say smooth. Or I said to you like there's something is rolling on a bar and this bar is a smooth, so that means that there's no friction, okay? All right, so I put all the forces, and then I have to analyze these forces. Like right now I did XY coordinate system. You need to find the summation of the forces in the X direction and the summation of the forces in the Y direction. So if you want to be organized in solving the problem, you can say X direction, and then you start by the sum of Fx is equal to MAX. Same thing here. Y direction, and then the sum of the forces in the Y direction is equal to MAY. All right, so first is that you need to figure out what is the sign of AX. The AX is negative, so you need to convert this from AX, it's gonna be negative. Why? There's no Y direction because I assume that the coordinate system is in the same direction of the motion, so there is no Y acceleration. This body's not moving in the Y direction. So this bar is 0, and this one is negative MAX. What if in your problem you assume that the X direction this way and Y direction is this way? So you are gonna have both. AX and AY. Why? Because the body's gonna move this way. So you need to find out the component of the acceleration in the X and in the Y direction. That's why I made it this way to make it more easier for me, and I don't have to find sine theta and cosine theta. However, anyway, I need to find sine theta and cosine theta for these forces. Why? Because here I have N. N is cooperating with me. All N is in the positive Y direction. F friction, all of F the friction is in the positive X direction. So what is the stubborn component? It's B and W. Okay, let's leave B. Let's just focus on W. So if this is my coordinate system, so I need to find the component of W in the X direction and in the Y direction. So I have to find the thetas, right? So do you guys know what is the value of this angle? Not 4, I didn't mention it, I only have, this is theta. Okay, let's put it here. So if, like this, and this is the vertical, this is the horizontal, but I have W is going down, W is something like this. But my X direction is in this way. This is my X direction. And this is the Y direction, right? And I want to find the component of W in these two directions. Right? Okay. And I have this angle at theta. Alright. So let's do geometry right now. This angle plus this angle is equal to 90 degrees, right?
and this angle is equal to 90 degrees. So since then, so this angle is theta, right? Because this theta plus x is equal to 90, so theta plus x is equal to 90. So this is theta, and this is going to be equal to theta, right? So right now you know what is this angle is. So right now you will have, this is w cosine theta, and this is w sine theta. So right now you have all the component of the forces. Same thing with b. So if we know that the angle, this is phi, so you're going to have b cosine phi and b sine phi, right? Okay, so this is actually in general how to make the coordinate system and how to draw the free body diagram with all the forces, because this is going to help you solve the problem. If you made this wrong, the whole problem is going to be wrong. Okay, let's say that you did the free body diagram right and you make the coordinate system. Then number 4 is to apply sum of the forces is equal to MA, and that's what we did here. MAY and MAX. And number 5, I'm going to give you a note. Don't forget about other kinematics equations. What does I mean by that? The relationship between the position, the velocity, and acceleration, because sometimes we will need them. Sometimes I'm not going to give you A directly. I'm going to give you velocity to get A. Number 6, solve and use common sense to check your work. Okay? Like sometimes you will have to, if you get a very, very big number, so there's something wrong. Maybe you mess with the units. Maybe you mess with the numbers. Maybe you didn't convert it from mass to weight. Okay? So, right, so let's solve a problem and see how this works. I'm going to give you an example, something like exactly like this. So let's example. So this example says that there's a skier is skiing on a steep slope. So we have a slope like this, and you have a skier somewhere here. I'm gonna make it like a mass, something like that. And it started at rest, okay? We will use this information. A skier started at rest on a slope. This slope is 40 degrees with the horizontal. And it says that he traveled 20 meters horizontally, like this skier traveled 20 meters horizontally. I don't care the y direction. And he cut this 20 meters in 2.85 seconds. So if in any Newtonian kinetics problem, I didn't give you the acceleration directly, and I give you distance, velocity, you will have to use the kinematics equation, like the relationship between the position, the velocity, and acceleration to get them. So if I want to do this first, and from what I see, let's say that this body has a mass m. I didn't give you the mass of the body. Like I said, it's m. Okay. And what I'm asking for, what is the kinetic friction coefficient? What is the kinetic friction coefficient? What does it mean? Right, forget to tell you something up here. When we put F of friction, you guys know what is the F of friction is equal to, right? You guys got it in statics. F of friction is the mu static multiplied by its function in what? In the normal force. So if the body is very, very heavy, like if I put my hand like this, and I put it very, very softly, and you just push it, it's gonna move. But when I put more force, it's more friction. There's more interlocking with the body, so you need more force to overcome this friction, right? And let me ask you, so okay, let's put F of friction is static is equal to mu static multiplied by the normal force. And if we are talking about F of friction dynamic, or kinetics, so it's a mu k multiplied by the normal force. Both of them are function in the normal force. But here, if the body's not moving, so it's a mu static. If the body's moving, it's a mu kinetic. What do you guys think? Which one is bigger, mu static or mu kinetic? Static. Why? Because in the static, when the body is static, there is more interlocking with the molecules of the two bodies. But when the body is moving, so there is less contact between two of them. So the kinetic is less. Okay, so you have static. I don't care about this one now. We are in the dynamic course. So it's F of friction, mu kinetic multiplied by N. So this is always function in this. All right? Let's get back to our problem. So what I'm asking here, I'm asking for the coefficient of kinetic friction. That's all what I'm asking for. I didn't ask you for acceleration. I didn't ask you for normal force. And I didn't even give you the mass of the body. Why? Because this is mass independent problem. We're gonna find out how this mass is gonna go out from our problem. All right, so the first thing is we need to follow the rules. It chooses the body to isolate. It's the mass of the skier, okay? All right, second one is to pick a coordinate system. Since it's moving linearly, yes, it's a sloped surface, but it's still linearly, so I'm gonna use Cartesian coordinate system. It's not curved to use tangent normal or polar. I did step number 3, and I'm gonna draw a free body diagram. So let's get this body out. I'm gonna draw 2. Let's say that this body is something. Okay, let's put a circle and another one. And I'm gonna say that this is the kinetic diagram and this is the free body diagram. Let's put all the forces on this body. But let's do the kinetic diagram first. I'm gonna assume that this is the x direction and this is the y direction. By the way, I uploaded the notes. Did you guys see it?
Yes.
This morning. So I'm gonna follow the same coordinate system directions that I put in the notes. So x in this direction and y this direction. I'm gonna assume that the acceleration, this body's moving down. So I'm gonna say that the acceleration is this way. So this is the ma. So this is called kinetic diagram. Has only coordinate and the acceleration direction. Let's put the forces here. Okay. This body has a mass and weight, and always the mass and weight is going down in the gravity direction. So we have weight is going down. Assuming this body is moving this way, so I always have a friction on the other way. And there is a normal force perpendicular to the surface, and it's always perpendicular to the surface this way. Do I have any other forces? I don't think so. Right? So I have weight, I have friction, I have everything. I put them here, and here's the angle. It's 40 degrees. And let's put the angle here. So I know that this is the x direction, so I have n is in the y direction and ff is in the positive x direction, and I have this angle at theta and this angle at theta, so you have two components here to this w. All right, so let's go to step number 4. Apply f is equal to ma. So I have two components. I have x direction and y direction. X direction and y direction. I'm gonna solve y first. Why? Because I know that there is no acceleration in the y direction, so it's gonna be an easy to solve first. So I'm gonna say that the sum of the forces in the y direction is equal to may, and this may is equal to 0. Okay, so the right hand side is equal to 0, but let's find out what is in the left hand side. What is the forces in the y direction? The weight, but what is the easiest? It's the normal, because it doesn't have any component and it's in the positive direction, so I have normal, right? The second one is the component of the weight in the y direction. So if this angle is theta, so what component that I have? Cosine component. So I have negative w cosine theta is equal to 0. So I can write this as n is equal to mg cosine theta, right? So I got the normal force. All right, if I have the normal force, I can figure out that the friction force, F of friction, is the mu k, which is the, what I'm asking for here, multiplied by m. So this is gonna be mu k multiplied by mg cosine theta. Okay, so right now I find out what is the F of friction is equal to. Let's get back to the x direction. So what is the forces in the x direction? So I have to write the equation, the sum of the forces in the x is equal to max. But I'm gonna make max is equal to negative because it's in the opposite direction of the positive x-axis. Okay, so I found out this. Let's find out the sum of the forces in the x. What is the forces that I have? I have F of friction, and it's positive, and the component of the weight in the x direction, which is negative w, and it's the sine component, and it's equal to negative max. F of friction, I have it here, mu k multiplied by the mass g sine theta minus w, which is mg sine theta. You guys see this?
Yep.
Right. Equal to negative max. I told you that this is mass independent problem. Why? Because here you can divide by the mass. This mass is gone, this mass is gone, this mass is gone from the equation. Alright? So if I know, and actually I know G, it's 9.81, and I know cosine theta because I can get cosine 40, and this is 9.81, and this is sine 40, so I know everything here except mu k. And I don't know ax, right? If I found ax, I can get mu k. How can I get ax? I give you some information at the verse. I told you that this body cut a distance 20 meters in 2.85 seconds, right? So this information, since I give you distance, and I give you time, or I give you velocity, and I give you time, that means that you can get the acceleration on your own. Okay? How can I do this? So first you will be confused. Should I use constant acceleration or should I use variable acceleration? We are going to use constant acceleration. Why? Because this body is moving under gravitational force. There is no external forces that are changing over time that is affecting this body motion. It's still moving under gravity. Not the full gravity, maybe a component of the gravity, but it's still constant.
Will it vary when we have to use like variable gravity or constant acceleration?
Like if you have a variable force over time that is moving this body. If it's a still constant force, it's gonna be constant acceleration. Okay? Because for example, we said F is equal to ma, right? If F is constant and the mass is still constant, so the acceleration is gonna be constant.
Let's say in the case it's like if this was a sphere and I was behind the sphere and I was pushing it in the same way.
Yeah, if you push him with a constant force,
It's still
it's still constant. But if the force is variable over time,
Yeah.
so it's not constant. By the way, this rule, the sum of F is equal to ma, is valid if the mass is constant. You're gonna say, okay, how's the mass can it change? Sometimes there's some problems that the mass can change. Like for example, if a rock is sliding from a mountain, and this rock, while sliding, it keeps getting cracks and lose parts of its body. So the mass of the rock is keep changing as soon as it cuts more distance. So if you have a mass variable problem, this rule is gonna be actually this rule from versatile principle. Let's write it in red. Force is equal to the time derivative of the linear momentum of the body. Okay? mv is the linear momentum of the body, mass multiplied by velocity. If the mass is constant, which is here, our rule here, I can get it out of the derivative, right? If it's not variable. So I can get it out, and then you will be left out with dv dt, which is the acceleration, right? So this just if the mass is keep changing, right? So like for example, if I give you that a body's moving, a rock or something is moving under the mountain, and the mass is equal to 5t, or negative whatever, like a decreasing function. alright? So you are gonna put them in the derivative with the v and differentiate both of them. And how can I differentiate two variables? I told you last time, the derivative of the first multiplied by the second, plus the derivative of the second multiplied by the first.
Okay, so this is just for your notes. Let's get back here. All right, so I'm gonna use this too, and this is actually a constant acceleration problem.
And actually I'll put you the full
Reasons why it's a constant acceleration in the note. So if this is a constant acceleration, you'll find out that x minus x node is gonna be equal, if you guys remember, and if I remember, I think it was v node multiplied by t minus t node plus half the a constant t square minus t node square, right? Or all square, whatever. T node is 0, why? Because I told you in this problem the body start is from rest, so x node is 0, t node is 0, velocity is 0, so all t nodes and every initial conditions are 0. So find out that x is equal to v node t plus half a and multiplied by t squared. Actually the a is x, because I put my x-axis this way, like the acceleration is moving this way, m-a-x. I need to find ax, and I have time. Did I give velocity? Yeah, v node is equal to 0 because it's the initial condition. So v node t minus t node and all this is equal to 0 as well. So the thing is, you have x and you have t, so let's put this as 0. X is 20 meter and it's this way, okay? X direction is this way, so the x is gonna be negative or positive. So I'm saying that the body's moving at x direction this way, 20 meters. And actually, this is not horizontal. Let's make it right. I mean by this distance, like this way. Cut horizontal, let's write it here. 20 meters. And 2.58 seconds. Alright, so the whole 20 meters is in the same is in the opposite direction of x, so it's gonna be negative 20. But if I told you the horizontal distance is 20, so you need to find what is the total distance in the x direction. Okay? Alright. So negative 20 is equal to half multiplied by ax multiplied by t squared, which is 2.58 squared. So you can get ax is going to be equal to negative 6.009. Negative 6.009 meter per second squared. Alright, so I got ax. So right now I can substitute in this equation to get the value of mu k. So this equation is going to be, like if I put ax is going to be negative 6.009, this one, and then the right hand side I'm going to put it here. Once you multiply 9.81 cosine 40, so this is going to be 6, let's put 6.31 minus mu k, 7.51. So this is my equation. 6.31 is this part, and this is the 7.51. Right now you can get mu k. Mu k is going to be equal to 0.04. This is the dynamic friction coefficient. Alright, so what did I do here? I followed the same steps here. Okay, I choose the body, I isolate it, I choose the coordinate system, I drew the free body diagram, I put all the forces, and I used the Newton's second law, and then I put sum of fx, sum of fy. The first equation got me the normal force, and from the normal force I got the f of friction, which is function in mu k, and then get back to the x direction, and then I solved all of this, and then I found out that I don't have the acceleration. I used the information given about the distance and the time, and I got the acceleration. I substitute in this equation, and I got the final mu k.
Just for like a good reference, you said number 6, use common sense to check. Just so we know, like with the coefficients of friction, it's always a very small number, right?
Yes, that's why I'm saying common sense. Like if you got it like 0.5, that's not right. That's too high. It's 0.4. It depends on the surface, but it's still like if it's a very, very rough surface,
So it's gonna be more, but it's not gonna be like 0.5 or 0.6.
Yeah, exactly. So it's like you get like 3 years.
Yeah.
Too much.
And it's definitely rule 1. Like if you got 2 or 3, that's definitely not true. Okay, so let's solve another problem that has a new thing.
Question.
Yes.
Does the 6.009, is that positive or negative?
Negative.
Because I thought there was already
This
a
one?
negative in the equation.
This
so-
one?
Yeah.
Okay, so what I did here, I have, this is negative, right? So we are saying if we substitute with this, it's gonna be positive, right?
Yeah.
Okay, so let's look at the signs here. I put mu k is negative. So what I did, I multiplied all this equation by negative. So this has become negative,
Okay.
positive, positive, right? So the positive here, I put this negative, and this start to be like the same thing. Like here, this one is negative, and this one is positive, because I changed it. So if you solve it step by step, you'll find that the signs are right. By the way, the signs are very, very important. So try to manipulate the equation as much as to make it easy for you. Like for example, I hate to see the acceleration is negative. So I make one this is positive, and I change the signs of the other thing. But once I changed it to positive, I found that it's already negative. So I put it negative back. Right? Okay, so does anybody have any question?
The equation, the finding mu,
This one?
it comes from the bottom one, right?
This one?
After canceling the mass.
Yeah, after I divided by the mass. Okay, so let's solve another problem that has a new idea. So right now it says that I have sample 13.4. I have a bar like this, and this bar has a sliding color, something like this. This is color, and this color, this is a new thing. I need your focus. This color is attached to a spring. So you have a spring here, and a spring is attached to a hinge here. And I'm giving you some information about the color. So I'm telling you that the color is mass equal to 2 kilograms, attaching to a spring that has a stiffness equal to 3 Newton per meter. Unrestricted length of the spring, so the spring here at this position is unrestricted, is 0.75 meter. So L node of the spring is 0.75 meter. If the collar is released at rest, so I'm saying here that this is rest, okay? And it moves down until it gets to this position. Okay, so right now I'm not saying that this is two springs. The collar was here and then moved down, so the spring, what is going to happen to the spring? It's going to be stretched. So I'm asking you to determine that the acceleration of the body and the normal force. That's what I'm asking for. Okay, let's understand the problem before we solve it. That's the first thing. Before you do this. Alright, so you have something here is attached to the spring, and this, when you leave it from rest, is gonna fall down. Okay? So let's understand the spring first. Have you guys solved any spring problem before? What is the force inside the spring? Yes? So any spring, like let's say we have a spring here, and this spring has a force F. So the force inside the spring is always always opposite to the force, the applied force. So the spring has a force Fk, or F spring, or Fs, is equal to K multiplied by the delta caused by this force. Like let's say after you apply this force, this spring was compressed and become like something like here. So it got compressed by distance delta. So delta multiplied by k, right? And actually we use the spring models when we solve the foundations of the structures. Why? Because if you have a structure and it's rested on a soil, the soil is not stiff. The soil is a compressible, compressible media. So if we have like a foundation, like a raft foundation, so the soil we model it like a spring like this that has a stiffness, okay, something like this. And if we found the forces in the springs, we found the force, the reaction from the soil on the foundation, and then we can design the foundation. But let's focus on the spring here. So we said that the F spring is equal to K multiplied by delta. So we need to find out what is the K value of the spring. Let's say if this spring is starting to be very, very stiff, so the force is gonna be much more higher. Okay, but I give you K is constant. K is 3 Newton per meter. So I need to find out what is the delta inside the spring. So I need to find the initial distance of the spring, and it says that the unstretched length is 0.75 meters. So I need to find the final length, this length, L final, and this is L node. All right, so here this distance is y. It's given y, and I'm asking you to determine the acceleration and the normal at y equal 1 meter. So let's find out what about this triangle. So if I found the angle theta, I can find L. So I have this is 0.75, and I have this is y. So L is the root of 0.75 squared plus y squared. So L is equal to root y squared plus 0.75 squared. So delta spring is equal to, so I found the final length of the spring, and I have the L node of the spring. Delta, as I said, it's the initial distance, sorry, the initial length minus the final length. So this is L node, and this is everything okay?
Yeah, just,
All right.
chair broke on me.
So delta S is L minus L node. Sometimes L is negative. How? If the spring is compressed. If the spring is compressed, so the spring has a compression. So if the L is, like if I said that delta here is L minus L node, and actually here is L is smaller than L node, so this is gonna be negative. So that means that this spring is compressed, and the forces inside the spring is a compression. If delta is positive, that means the spring is under tension. Okay? Like the same problem, like this problem here. So this spring is getting much longer, so it has tension. Alright, so I got the final length L, and delta S is gonna L minus L node, and I can say that this is root y squared plus 0.75 squared minus L node, which is 0.75. So this is delta S. If you want to get the force inside the spring, it's going to be K multiplied by delta S, and K is equal to 3 newtons, so 3 root y squared plus 0.75 squared, and I have out is 0.75. Does anybody have any question? How did I get the force inside the spring? Again, very simple. The force in any spring is the stiffness of the spring multiplied by the compression or the delta that the spring had. And if delta is negative, that means it has compression. If it's positive, it has tension. How did I get delta? I have L node and I have the final L. So L minus L node is going to give you delta, and then multiply delta by K, you get the force inside the spring. Right, so we are done with the spring bar. So right now I understand the problem. This color is saying it's smooth, it's a smooth. What smooth mean? There is no friction, so I don't have any friction in this problem. But if I mention, for example, that it is not as smooth and I give you coefficient of friction, you have to include friction. Okay, so what is the forces act on this color or in this body at this instant? So let's do a free body diagram and kinetic diagram. So I have it here. I'm gonna draw the kinetic diagram, and another one, a free body diagram. Let's put on the kinetic diagram, I'm gonna assume that this is the x direction, and this is the y direction, and it's moving down, so I'm gonna say this is MA, and definitely it's in the y direction. Let's get to the free body. What is the forces on this body?
I have a question real quick.
Sure.
What was K for again, Professor?
K is the stiffness of the spring. If the spring is very, very stiff, so the K value is gonna be high. Alright. Okay, let's get back to the free body diagram. What is the forces on this collar? Spring? The spring. Let's put the spring first. Okay, so you have, this is the x-axis, and you have if the spring is going this way, right? Because, and it has angle theta. Alright, what is the other forces that we have? And why did I assume that the F spring in this direction? Why it's not the other way? Because it's tension, right? So this spring is like, it has forces like this way, like if this spring is elongated, so this one is pulling this way, okay? Okay, let's escape this. What other forces that this body has? Normal. And what is the direction? Okay, if this spring is pulling this way, so the normal force is in the other way, right? Normal force. Hmm? Yes, I'm gonna ask for the next force. The weight, right? The weight is going down. Right? So I have the weight and the weight and the normal doesn't have component. All the weight is in the negative y direction, and all the normal force is in the negative x direction. So the only one that has components in x and y is the F spring. Okay. So I have everything here, so let's start solving the problem. What is the next step? X direction and y direction. The sum of the forces. X is equal to MAX, and I know that the X is 0, so I cross X, but let's find what forces that we have in the X direction. So I have Fs cosine theta minus N is equal to 0. So let's find the angle theta, solving some geometry here. You guys can tell me what is the sine theta from this geometry? This is y, this is 0.75. What is the value of the theta? Sine is the opposite, y over L, which is the root y squared plus 0.75 squared. Same thing. What is the cosine theta? Is the tangent 0.75 over the root y squared plus 0.75 squared. So I have cosine theta and sine theta. So I can say that the normal is equal to Fs, I got Fs here, right? 3. And by the way, I'm asking about the normal and the acceleration at y equal 1 meter. So I'm going to substitute with y equal 1 meter. So I have 3 multiplied by root 1 squared plus 0.75 squared minus 0.75 squared. So I got all Fs. Next thing, I multiply by cosine theta. Cosine theta is 0.75 over the root 1 squared plus 0.75 squared, and that's it. Oh, sorry. This is big bracket, so 3 multiplied by this bracket, and all this is multiplied by cosine theta. Once you solve this, you'll find out that the normal force is equal to 0.25. This one? This one is not. Yeah, because it's absolute length. So you'll find that the normal force is 0.9 meters. So I got the first thing I'm asking for, A. So let's find what is the value of the acceleration in the y direction. So to do this, I'm gonna make the summation of the forces in the y direction. I'm gonna write it over here, I'm gonna write it in black. So the sum of the forces in the y is equal to MAY. So let's find what forces that we have in y. I have W is in negative, I have Fs in positive, so I have Fs sine theta minus W equal to MAY, so it's a negative MAY because it's in the opposite direction. I have Fs is 3 multiplied by root 1 square plus 0.75 square minus 0.75. This is Fs, I got it from over there. Sine theta, I got it, it's y, which is 1 meter over the root of 0.75 square plus 1 square. Minus the weight. The weight is, I give you the mass is 2 kilograms. So the weight is 2 multiplied by 9.81. And this is equal to minus 2 multiplied by 8y. So the only variable that I have here is ay. So once you do the calculation, you'll find that ay is equal to 9.21 meter per second squared. Does anybody have any question on this?
Do you have normal C, normal S? Is that
This is the normal, yeah.
just, but your notation is N
And C, you can call it N. In the color, like for the color itself. Okay, so you can call it N, and this is, you can call it WC, but since we have only one body, you can call it whatever you want, N and W.
Okay. And number one, you provided with y is equal to 1 after or that?
This Y?
No, y equals 1, you got it from.
Oh yeah, this is given in the problem. I'm asking you that you get the acceleration and the normal force once you get this at 1. If it's at 2, it's gonna be different answer. So this is, the acceleration and the normal force is changing as this particle is going down. Does anybody have any other question?
Do we have to make our coordinate system like that? Can we flip it around and make y going down?
Yeah, you can flip y going down, it's gonna make it, and actually, here in the solution, in the textbook, it makes y going down,
Okay.
okay? Alright. Yeah.
Where you have n equals 3, what is the n bracket for?
Which one?
On the x direction.
This one?
Yeah, what is the n and then you have a...
Okay, so since here we said that n force, like Fs cosine theta minus n is equal to 0. So n is equal to Fs cosine theta.
Yeah.
And Fs, we got it here, it's equal to k multiplied by delta.
Yeah.
And k is 3, and delta is all this bracket. So this is the bracket that you are looking for. So I put all the bracket here, but I replace the y with 1.
Yeah.
If I ask it 2, you can make actually the whole problem as a function in y, and at the final answer, you just substitute y is equal to 1. Alright, but let's actually make something that is not here. What if I ask you for the velocity, but before this, does the 9.21 make sense? Why? Let's say if you got it 10, does it make sense? Let's say body's falling, okay? So if I let this body fall like this, it's gonna be, acceleration is gonna be 9.81. But is this body is attached to a spring? So this spring is decreasing the acceleration of the body. So it becomes 9.21. Let's say I make the stiffness of the spring is equal to 100. What do you think? I might ask you this in a quiz or something. If you increase the stiffness of the spring, what is going to happen to the acceleration of the body? Is going to be increased. Because the stiffness is going to be big, so it's more tension that pulling the body, so the acceleration is going to go down. If the stiffness of the spring is going to get less, so the acceleration is going to get higher. Let's say that the spring stiffness becomes 0. What is this is going to be? It's going to be 9.81. What is going to be confusing is solving this problem from first step. If you get this as 8, it makes sense as well. And if it's a 7, it makes sense because you don't know, right? But if it's got like more than 9.81, no, there's something wrong. All right, so So let's actually tell you some like idea for other problems without solving them. Like, so let's say that we have, I'm gonna apply the principle of Newtonian kinetics in the dependent motion. Like you have a fixed surface like this, and you have a pulley here, and there's a wire, and there's a weight here attached, and this weight is A, and this weight is B, right? And I told you the masses of the two weights. This mass is 100 kilogram, and this mass is 20 kilogram. What do you think? Is this mass is gonna go up or down? It's gonna go up, right? Because 100 kilogram is gonna go down and pull this up. I assume this, when I solve this problem, is gonna go down. So everything got negative. You can assume whatever you want. So you can assume this is going up, this is going down. But how can I solve this problem? How many bodies that I have in this problem? I have two moving bodies, right? I have A and I have B. So you'll have to have two body diagrams. One for A and one for B. So you have here A and B. What is the forces on A? The weight, definitely. In any problem. So you have W going down, and this one, W is going down. This is 20 multiplied by 9.81, and this is 100 multiplied by 9.81. What else? Tension. And if this is the same rod, the same cord, so all the tension in this rod is always constant. Like the tension here is equal to the tension here is equal to the tension here. If you cut the rod and measure the force, so the tension is always equal, okay? So this one has T coming from just one cord attached to this body, but this one has 2T coming from two pieces of the rod. So this one has T and has T, it makes 2T. So this is something to think about, right? So this is because it has two tension coming from the two pieces of the cord.
But it's just connected to that one cord right there, so.
This one is connected to only one cord, this one.
Yeah.
So I have to cut here and cut here to make the free body diagram.
Okay.
So all the forces, the 2T is transferred to the pulley and then transferred to this one, okay? So actually, you have a T here and T here, and then you have 2T here is transferred to this A. So I put 2T. All right, so I got everybody separated. You are gonna apply the Newtonian kinetics for this body and the Newtonian kinetics for this body. And then you are gonna use the relationship between the two bodies. How? You need to build a relationship like this is fixed, and this is YB, and this is YA. And then you will find out that 2YA plus YB is equal constant, right? Then the same thing, this is the two velocity of A plus the velocity of B, if you take d dt for both sides, is equal to 0. And the two acceleration, 2AA plus AB, is equal to 0. So you made a relationship between the acceleration here and the acceleration here. Why I'm doing this? Because both of them has the same variable, like this has t and this has t, okay? So, but you are gonna get, once you solve the Newtonian kinetics, you are gonna get the acceleration, the body is a function of acceleration of B, and this body is acceleration of A. So you'll have three variables, T, AA, and AB. I have two equations and three unknowns, but you are gonna get another equation coming from here, so you're gonna get a third equation. So you're gonna use this as a third equation to solve the problem, alright? Because for sum of Fy, you are gonna get this, and the sum of Fy for body B, you are gonna get this. So this is gonna give you one equation, and this is the second equation, and this is the third equation. To get what? To get t, and to get the a of b, and the a of a. The three unknowns, right? Everybody got that? Everyone got that? All right. For this problem, the one that has a spring, I can't make it horizontal. It's gonna be, it can be totally different. Like if I have this bar like this, and I make the collar here, and there's no gravity here, so this one is moving this way, and the spring was unrestricted here, and I give you the unrestricted length is like 1 feet, and at some point it came here and got restricted. But actually, this one is not gonna move by itself because it's not moving down, it's not weight. So you'll have to push it, do something, give it initial velocity, do something to move it. So I give you in the problem that there's a velocity here, v naught is like 15, I think. Yeah, 15 feet per second. Right? And it got distance s. And it's gonna be the same thing. You are gonna like take this and do a free body diagram. You will have a weight is going down, and you will have a normal forces going up, and then the spring force is gonna be something like this. So it's gonna be Fs. So you have, this is S. And actually, I gave you that S is equal to 1 as well. Like, what if S determine the velocity? When S is equal to 1 feet. So you know this and you know this, so you can get theta, and you solve the same problem by understanding how these forces act in each other. So you have the weight is going down, so the normal force is going this way. All right, and there is no friction as well. So this body is moving this way, so there is no friction that impacting this body, and then you solve it. And I believe there is no trick here, unless that I ask it for the velocity. So you will find out that, for example, when you say the sum of Fx is equal to max, so we'll find all the forces in the x direction. So you will find that this is the only force that makes x component, so it's gonna be negative Fs cosine theta is equal to max. It's gonna be something like this. I'm just giving you an idea. How does the equation look like? So you will know Fs, you will be able to get it because it's the K multiplied by delta, and you know L node, and you know L. You can get Fs. It will be very easy to get. You know cosine theta because you know the distance, like you know the tangent and the horizontal and everything, so you can get theta. You know the mass. You have the acceleration. Once you get the acceleration, you will be able to get the velocity. But the thing is, the acceleration is keep changing over time, and this starts from v naught equal 15 to a final v. So you need to make this function, like you need to convert this x, if you guys remember, it was equal v dv ds. And ds here is in the x direction, so it's x, or you can call it s, whatever you make the variable is. And then you have to put ds here and integrate this function from s naught to s, and from v naught to v. You'll find the full solution here. Okay, how you did this. There's many problems that can be like tweaked to make it a little bit difficult. But once you understand the main idea about every problem, you will be able, that's why I asked you to look, what is the forces that you have? The weight, the normal force, the spring force, any external force, you need to put all of them on the free body diagram. All right, so the quiz is gonna, I believe it start right now. You have until the end of the day to take the quiz anytime. Try to concentrate. I give you the tip. Try to study, and hopefully you will get it right. It's 20 minutes. It's very easy. One question.
Physics 2 is a lot. Physics 2 isn't this. I hated physics.